Very good evening everyone. Now this is Swapna. Here I am to take chemistry classes. Today we are going to learn about acids, bases and salts, a chapter from ICSE which is very important and high weightage chapter. See here, acids, bases and salts. Before entering into the session, I want to ask you, is it compulsory to enter into chemistry lab to study about acids, bases and salts? Definitely no. See, in our day-to-day life, we will see a lot of acids, a lot of bases and salts in the house, in kitchen especially. So in this session, we will learn what is acid, what is base and about their properties, how to find whether the given chemical is acid or base. See, if we are thinking about in our day-to-day life, different substances are there. For example, lemon. If we are talking about lemon, we will feel it is sour in taste, right, which is an acid, and soap, which is a base, milk, which is a mild acidic, and common salt, which we will use in the curries. See, other than these, so many substances are there. For example, curd. If we are taking the curd, it contains lactobacillus bacteria and it contains lactic acid, so we will say it is an acid. So like that, in our day-to-day life, so many substances are there, so we can study about acids, bases and salts even in our kitchen itself, in the house itself, without entering into the chemistry lab. So first we will learn about the acids. What do you mean by acid? An acid is nothing but, generally it tastes sour. What is the taste of acids? Taste of acid is sour in nature, and generally if we are adding acids in the water, it releases hydronium ions. Which ion ma? Hydronium ions it will release. An acid is a substance, generally it is sour in taste, and in the presence of water it releases hydronium ion. How? For example, if we are taking HCl, hydrochloric acid, and we are adding HCl in the water, so normally check HCl, it exists as H plus and Cl minus. In the presence of water, this H plus and H2O, it results in the formation of H3O plus, which we are calling it as hydronium ions. By release of this ion, H3O plus ion, we are calling it as acidic character. So this is about acids. Acids generally it will release H3O plus ions in the presence of water. For example, if I am saying dry hydrochloric acid, dry hydrochloric acid, dry HCl. If I am asking, is it acidic in nature or basic in nature, or what is the nature of dry HCl? Will you say is it acidic? Definitely no, because it is compulsory for any acid or any base we have to check in the presence of water. Means in the presence of water only, any acid it will release H3O plus ions, then only we will say it is acidic in nature. If we are talking about dry hydrochloric acid, it is not an acid because it will not release any H plus or H3O plus ions. So in our day-to-day life, we will see so many acids, right? For example, vinegar. Vinegar which we will use in the kitchen, it contains acidic acid and its formula is CH3COOH. Okay, like that. In the stomach, which acid is present? Hydrochloric acid is present, and in citrus fruits like lemon, it contains citric acid. So like this, in our day-to-day life itself, we will see so many acids, and for acids generally they are sour in taste, and it is compulsory to check whether in order to show their character, their acidic character, it is compulsory we have to add in the water, then only they will release H3O plus ions. This is all about acids. Then move to the next one, What is next one, ma? After acids, bases. So what do you mean by bases? Bases generally they are bitter in nature. Bases are generally they are bitter in nature. Bases are generally bitter in nature, and similarly like acids, if you are taking bases in the water, it will release, bases will release OH minus ions. If they are releasing OH minus ions, we will call it as bases. Okay. Now here you can see a substance that reacts with an acid to form saltide water. Generally bases they will react with the acids in order to form saltide water. See, there are so many bases are there. Some bases will dissolve in water and some bases they will not dissolve in water. If the bases which will dissolve means which are soluble in water, we will call it as alkali. Alkali means the bases which will dissolve in water. See, here we can say all alkalis are, which are alkali in nature, they are bases, but all bases are not alkali. Okay. Here examples NaOH, if you are taking NaOH pellets and if you are adding it into the water and stirring it for some time, definitely you will see those NaOH pellets or KOH pellets, they will dissolve in the water and releases OH minus ions. So these are bases, and as they are soluble, as they are dissolving in the water, we will call it as alkali. This is all about bases. Normally bases are slippery in nature. For example, if you are taking soap, soap is slippery in nature or not? It is slippery in nature, and soap is an example for the bases. So next topic, for example, now we know what is acid, what is base. For example, if I am giving you two beakers, assume that I am giving you two beakers which one contains hydrochloric acid and other contains NaOH solution. I have prepared these two solutions for you and I have kept in front of you and I asked you to say which one is sodium hydroxide solution and which one is hydrochloric solution. Generally these two looks similar, looks like water itself. So directly by saying, is it possible to say whether which beaker contains NaOH solution and which beaker contains HCl solution? Definitely no. So something should be there, right? In order to check whether the given chemical is acidic in nature or basic in nature, we need to use some substances, and those substances only will call it as acids. Those substances only will call it as indicators. Indicators are the substances that show characteristic color change in acids or in alkaline medium. So here we are having two types of indicators. One is natural indicator, and another one is artificial or synthetic indicators. Natural indicators means what now? Natural indicators means directly we are getting from the nature, whereas synthetic or artificial indicators means the indicators which are prepared by the man. So here we will discuss some indicators, some natural indicators and artificial indicators. First one is litmus. Litmus indicator, it may exist in the liquid form, we will get litmus solution, or else in terms of papers. For example, if we are talking about paper, it will be in blue color and it will be in red color. Litmus paper, it is of red color, we will get blue color litmus paper and also red color litmus paper. If we are taking a solution, for example here we took NaOH solution and HCl solution. Now we are taking litmus paper, blue litmus paper we are taking, and we are dipping that blue litmus paper in the HCl, hydrochloric acid. Now what will happen? As we are dipping blue litmus paper in HCl, it is acidic in nature, and in the solution it releases H3O plus ions, and this blue litmus paper, it turns into red color. Okay, blue litmus paper we have dipped in HCl solution. As H3O plus ions are there, it will turns into red color. Whereas if we are taking red color litmus paper and we are dipping into the NaOH solution, now what will happen? That red color litmus paper, it turns into blue color. Okay, okay, fine. Ma'am, you are taking blue color litmus paper and dipping it into the acid, we are getting red color, and we are taking red color litmus paper, we are dipping in the base, we are getting blue color. Fine. Now what will happen if I am taking red color litmus paper only in the acid? Okay, if we are taking blue color litmus paper, we are getting red. Now I will take red color litmus paper only. Now I will take red color litmus paper only in the acids. What will happen? So the answer is there is no change. If we are dipping red color litmus paper in the acids, it will not change into any color. Similarly, if we are taking blue color litmus paper and dipping it in the NaOH solution, then also there is no change in the color of the litmus. Now, this is one natural indicator. Now moving to the next one, methyl orange. This is one synthetic indicator which is prepared by the man, human being. Now methyl orange indicator in acids like HCl, sulfuric acid, in the presence of acids it will give red color, whereas in the bases it will give yellow color. Alcohol is nothing but bases. Methyl orange indicator in acids it will give red color, whereas in bases it will give yellow color. Now moving to the next one, one of the important indicator and very used, we will use regularly in the labs, phenolphthalein indicator. Phenolphthalein indicator in acids it will be colorless. In acids it will be colorless, whereas in bases it gives pink color. Phenolphthalein indicator is one of the important indicator. And the next one is pH paper. pH paper, it contains range. It contains range. pH scale, we will say pH scale. It starts from 0 and it's up to 14. Range of pH scale is 0 to 14. So here, if the pH is from 0 to 6, if we are getting any color in this from 0 to 6, we will call it as acidic in nature. Those are all acids. If we are getting 7, pH 7 if we are getting, then we will call it as neutral. Neutral means, what do you mean by neutral, ma? It is neither acidic nor basic. And above 7 means 8 to 14 if we are getting pH, then we will call it as basic in nature. So first one is 0 to 6, we will call it as acidic in nature, and if we are getting pH 7, that means it is neutral in nature, whereas 8 to 14 we will call it as basic in nature. And examples here I have given, pH 0 to 6 we will get lemon juice, and whereas neutral pure water, pure water means distilled water if you are taking, which will not contain any minerals. Distilled water means all the minerals are removed, only H2O molecules are there. That distilled water, it will show pH 7, which is neutral in nature. Next, pH 8 to 14 alkaline, example is soap solution. Other than soap solution, we can say window cleaners. We will use window cleaner bodies will be there. Those window cleaners also basic in nature. This is all about different types of indicators used in order to check acids, bases and salts. See, we have discussed about litmus indicator, which is a natural indicator, and methyl orange, phenolphthalein, pH paper, these are all synthetic man-made indicators. This is all about indicators, means by using indicators we can check whether the given chemical is acidic in nature or basic in nature. Now, one more natural indicator we can discuss, that is turmeric. You can make turmeric paste by mixing some water, then apply the turmeric paste on the paper. If you after drying, let it dry for 1 day, then cut it, take the paper and cut it into different pieces and put the turmeric paste paper in any solution, for example soap solution, surf solution or any shampoo solution, you make it and dip into that. Find, do this activity and find the answer, means what color you are getting, check it and let me know in the comment box. You will see that turmeric paste paper, it will turns into red color, means normally turmeric acts as a indicator. In acids it will not change any color, change, but in bases it will give red color. This is one of the important which we can get easily and easily getting indicator. Now see the next one, differences. We have learned about acids we have learned and bases we have learned. Different indicators also we have learned. Now see the differences, main differences between acids and bases. First one is, in acids we know H3O plus ion is released, hydronium. H3O plus ante enti ma, it will release hydronium ions. Next, in the bases we will get OH minus ion, we will call it as hydroxide. We will call it hydroxide ion. Whereas different indicators I have given here. See, in litmus solution, acids it will turns into red, whereas bases it turns into blue. Keep it in mind, bases starting with B and color also we are getting blue colors, which starting letter is B. This is very good trick to remember. Next, phenolphthalein. Acids, in the presence of phenolphthalein it gives colorless, whereas in bases it turns into pink color. What is next ma? Methyl orange. In acids it will give red color, whereas in bases it will give yellow color. And pH paper we have discussed that less than 7 we will call it as acids and exactly 7 we will call it as neutral, and greater than 7 we will call it as bases. This is all about acids and their chemical properties. Now we will see what will happen if acids reacts with bases. Generally acids will react with bases and it results in the formation of salt and water. Salt and water. Acids on reacting with the bases, it results in the formation of salt and water. So if you are taking example, see hydrochloric acid, its formula is HCl. On reacting with NaOH, sodium hydroxide, Na means sodium, OH means hydroxide, sodium hydroxide. On reaction between these two we are getting NaCl, salt and H2O. How? See, HCl solution we are taking. So in the water it will be like H plus and Cl minus. Now if you see NaOH, in the ionic state we can say Na plus and OH minus. We know generally south pole will repel, right? North pole will repel. In the similar way, south pole, north pole will attract. Here we can take opposite charges will react. See, H plus means it contains positive charge, Cl minus it contains negative charge. So this negative charge will form a bond with Na plus, which contains positive, we are getting NaCl, and H plus OH minus forms H2O water molecule, right? This is neutralization reaction. For example, instead of NaOH, if you are taking hydrochloric acid reacting with sodium bicarbonate, NaHCl. CO3, it is nothing but sodium bicarbonate. It results in the formation of HCl will react with NaHCO3, it results in the formation of NaCl, salt, and the next one is water. Along with these two, it will result in the formation of carbon dioxide also. Means this is in the bases. If you are taking the bases which contains carbonates or bicarbonates, instead of bicarbonate here NaHCO3 we took, instead of this we can take Na2CO3 also. So acids, when they are reacting with bases like bicarbonates or carbonates, along with NaCl, salt, and water, it also forms carbon dioxide. Okay. So what is the general formula we can write? Acids plus bases. Which bases? Carbonates or bicarbonates. Carbonates or bicarbonates, such type of bases, they will react and results in the formation of salt plus water plus carbon dioxide, CO2, carbon dioxide. So this is all about today's class. So this is a general formula for the general equation for acid. When acids are reacting with the bases, it results in the formation of salt and water. Now in our day-to-day life, there are so many applications are there for neutralization reaction. For example, sometimes we will feel very stomach upset after eating, right? So why we are feeling like that means it is indigestion, means it causes due to excess amount of hydrochloric acid present in the body. So what we will do? Normally people suggest to drink ENO, right? Then why they are suggesting like that? Because ENO contains base. So when we are drinking the ENO which contains base, it reacts with the excess hydrochloric acid present in our body and neutralizes. So salt will be formed. So we will feel somewhat relaxed after drinking ENO. So like that, so many applications are there, and we will continue this about different applications of neutralization topic, neutralization reaction, how it will be used in our day-to-day life, and some other topics also like how acids will react with the metals we will discuss in our next class. Thank you all.